Hi guys. Okay, so we're gonna do 1.3 day 3. So what we're gonna do to before we get going here is on the homepage, you guys can go straight to Schoology. At the very top, there's an online stats calculator. So we're gonna be using this today. So you're gonna want to click on that. As a side note, I plan to take down some calculators to the library tomorrow that can be checked out. A graphing calculator. I'm also gonna write down an app for you on the notes that you could use if you want to do that as well. Okay, so when you click on that, it brings you to an online stats calculator. Statscalculator.com is the website. If you just click this little arrow up here, it'll just open up a separate page, which I think is easier to work with. Okay. All right. So looking at our notes today, 1.3 day 3, we're going to calculate quartiles and something called the interquartile range. Okay, all a bunch of fancy words. This is real simple stuff, you guys. So let's just think about it this way. I think the word quartile, you guys think of quarters. Well, quarters, 25 cents of 100, 25%. All of that is exactly the same in statistics. And so think about this data set here to here. Well, this would be 100% of the way up, right? And I think you guys know that the median is located halfway there, right? 50% of the data is above the median and 50% below. This right here we call quartile 1, which is 25% of the way up from the min, okay, which is 0%, okay? This we also refer to as the max, which is 100%. And then here, right in the middle, would be 75% of the way up. We call that quartile 3. And, thinking about 4 quarters in a dollar, right? Quarter 1, quarter 2, we don't call it quarter 2, we call it the median, but it's the same thing, right? Quarter 3, 75% of the way up, and quarter 4, 4 out of 4 is a whole, or 100%. Okay, so we're going to figure out how to find quartile 1 and quartile 3. And then what we're going to do is we're going to hopefully remember that this distance, right, from the min to the max, we call the range. Right? From the min to the max, we call the range. And you guys learned that a long time ago. No big deal. So what happens if you go from quartile 1 to quartile 3? We call that the interquartile range. Okay, so it's still a range, right? It's just the interquartile range. So it's the distance from quartile 1 to quartile 3. Okay, so that's just some basic all the way there. 25% of the way, 50, 75, 100. From max to min is the range. If you only go from quartile 1 to quartile 3, you have an interquartile range. We call this IQR. Okay. All right. So let's get going here. So how to calculate the quartiles, quartile 1 and quartile 3, and the interquartile range. So just some basics here. I'm not going to have you guys do this by hand because you're at home and you're going to have a calculator regardless. And so we're not going to do it by hand. So these notes will go really quick because we just get to use that website. All right, so coming down here, we just talked about this type of stuff. The interquartile range, which we call the IQR, by definition, you guys, is quartile 3 minus quartile 1. That's just the range of the inner quartiles. Okay, most stats calculators will just tell you these individual things, and you have to do a simple subtraction to find the IQR. All right, so let's jump back here and talk about McDonald's fish and chicken sandwiches. Here are the amounts of fat, right? And we've seen these numbers before in fish and chicken sandwiches in order from least to greatest. Find the quartiles and the IQR of the data. So what they're asking us to find is the quartiles. You need quartile 1 and you need quartile 3. And they want the IQR, which by definition is quartile 3 minus quartile 1. So once we get these two numbers, we're good to go. Okay. All right. So I'm going to go back to my calculator, online stats calculator. And to use this, where is it? Here we go. All we have to do is click in this observations, right? You click there and everything goes away. And if you enter the fat content of the sandwiches separated by commas, 9, 14, 16, 19, 20, 22, 27, and 33. Okay, and then I come down here and I just hit calculate. And now, as I scroll down, there's a sample histogram of that data. Okay, you can see that the counts are over here, right? So again, what does this 1 mean? That means that there's one measurement that falls between 0 and 10. And if you scroll over it, it actually tells you what it is. It's this data point of 9. Okay, well, since this is a space of 10 here, they will all be spaced out by 10. That's just what a histogram is. And if you go from 10 grams of fat to 20 grams of fat, it seems like our count is up here at 3. So there are 3 data points that are in this range. You can see them. The fat content of 14 and 16 and 19. So this is a really handy website. Okay, and as you scroll down, it tells you descriptive statistics. So these are things about the data that you entered. And so we don't know all of them yet, but right here, check it out. We've got our minimum value is 9, 25th percentile. That is quartile 1, right? Sample median, 75th percentile, which is quartile 3, and it actually calculates the IQR straight for you. Okay, so you've got all of your data. And so I will write that down and then I'll switch back to the page so you can see it. But quartile 1 is 15.5. Quartile 3 is 23.25, and the IQR, they did it for us, it was 7.75. Okay, so if I go back here to the notes, all I did was I took the data from the website and I put it in. Okay, so not difficult, right? But now, as we move forward, we'll be able to use these numbers to create a graph and then to discuss other things about it. Okay, so finding these values should not be hard. You just type them into the website. Okay, so how to identify an outlier? Well, here we go, right? At this point, all we've been able to say is that, hey, it looks like there's a possible outlier in that data set. Now I'm going to give you an official way to find out if it is in fact an outlier. Okay, so it says call an observation an outlier if it's more than 1.5 times the IQR above the third quartile or below the first. That is confusing. So outlier if, okay, it's greater than quartile 3 plus 1.5 times the IQR, or less than quartile 1 minus 1.5 times the IQR. Okay, and this, it might look confusing, but I mean, you guys, we just used that website to find quartile 1, quartile 3, and IQR. So all I have to do is type in my data, get my descriptive statistics, fill this out, and then it is if it's bigger than this number, whatever that number equals. And it's an outlier if it's smaller than that number. Okay, and we'll do an example right here to pull it all together. So now we're moving on to beef sandwiches. They've got our fat content in order here, so I will go back to this website, click in my spot observations to start off with new data. So it's 9, 12, 19, 23, 24, 2 26s, 27, 2 29s, 31, and 43. Okay. And so I'm just going to check, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So that seems to be correct. I would click calculate and I'm going to get a sample histogram. Now let's pause for a second and think about what skills we should have at this point, right? Assuming you're paying attention in class and you're trying to keep up. This, it hasn't been horrible, I don't think, I hope, right? This looks like a graph, and could we describe it? If we described it, we would use the acronym SOX for shape, outliers, center, and spread. And we'd say, look, this thing looks roughly symmetric. Its measure of center would be somewhere here in the range of 20 to 30, right? It doesn't appear, right, that there are any outliers. So think about what I just said. By looking at this, you would have reported it does not appear that there are any outliers. Okay. Now we actually have an official way to find the outliers. Okay, so I'm going to write down these statistics on the note page. I got quartile 1 is 22. It told me that quartile 3 is 29, making the IQR equal to quartile 3 minus quartile 1, right? So 29 minus 22 gives us our interquartile range of 7. Okay, so let's go back now to our notes and let's calculate by hand to see if, in fact, there are any outliers. Okay, so we're going to use our definition. We're going to go calculate quartile 3 plus 1.5 times the IQR. Okay, and that's going to be 29 plus 1.5 times an IQR of 7. Okay, so get any calculator you want. If you type that in, 29 plus 1.5 times 7, you get 39.5. Okay, all right. So it said, look, it is an outlier officially if there are any data points that are bigger than that. So when I look at the data, are there any numbers bigger than 39.5? Yes. So then you would say, since 43 is greater than 39.5, 43 grams is an outlier with certainty. Okay? And so now we have that there is definitely an outlier on the high end, but we haven't done the low end. So now check quartile 1 minus 1.5 times the IQR, which would be 22 minus 1.5 of 7, which gives us 11.5. Okay, and if we do that, are there any data points that are below 11.5? Yes. And so I would say, since 9 is smaller than what I just calculated, 9 grams is an outlier. Okay, and so you have 2 outliers in this data set that we found using our rule officially, even though, right, when we looked at this, we wouldn't have reported it. Okay, because sometimes graphs don't necessarily tell you mathematically that that measurement right there, 43, is too far away from most of the data. And this measurement here, 9, same thing. It's too far away from where the majority of the data is. Okay. All right. Let's go back here to the notes and turn our page over and see what we got. Okay, so on the back, we are going to talk about the 5-number summary, which allows us use this to graph what we're going to call a box and whisker plot. Okay, and so we are learning another graph. Okay, and this one is probably one of the most common used in stats. Okay, so we've learned about a dot plot, we've learned about a stem plot, we've learned about a histogram. Okay, and now we are going to learn about a box and whisker plot. Okay, and this 5-number summary is really easy because, again, we're going to use the online calculator. We need minimum, quartile 1, median, quartile 3, max. All of those are given to us from our 5-number summary. Okay, so let's go back to our website, and I'm going to type these in: 10, 12, 13, 20, 24, 26, 27, 29, 30, 32, 34, 34, 38, 39, 39, 40, 40, 1, 2, 3, 4 44s, 45, and 47. And calculate. And so what those numbers are, you guys, if you're looking at your notes, it says the number of home runs that Hank Aaron hit in each of his 23 seasons. So right here it says sample has 23 observations. Always check that, right, to make sure that I type these in correct. Okay, and then you're looking at your graph here. This would definitely be skewed left, right? And then down below we have 1, 2, 3, 4, 5, ignoring the IQR, right, because that's not part of our 5-number summary. And so I will write that down on the notes, and then I'll go back. We have a min value of 10. We have a quartile 1 value of 26.5. We have a median, which is the middle of the data at 38. and we have a quartile 3 at 42, skipping IQR and just going to the max value of 47. Okay, and so I have written down what's called, right? This is the 5-number summary. Okay, so the 5-number summary is really helpful. It's helpful because now I can use those numbers to verify mathematically whether or not there are any outliers. Okay, so I think it's worth checking for outliers again. So let's check for outliers. And so I'm going to do quartile 3, and I'm going to add 1.5 times the IQR. The IQR was, I'll just write it down here. IQR is equal to 42 minus 26.5, which is 15.5. Okay, so I put that right there, and I get a number, 42 plus 1.5 times 15.5, and I get 65.25. Okay, so look at your data. Is there any number that's above that? No. So no high outliers. No, I don't know why I wrote not. No high outliers. Okay, then we need to do quartile 1, which is 26.5, and subtract 1.5 times the IQR. And if you do 26.5 minus 1.5 times 15.5, you get 3.25. And 10 is the smallest, so there's no data that's below that. So no low outliers. Okay, and so we checked both. Okay. All right, so we use the 5-number summary to quickly check for outliers. And now let's do a box whisker plot. Okay, so a box and whisker plot is pretty straightforward. You're going to draw a number line like always. Okay, and on that number line, we are going to put our minimum values here. Okay, and so if you got to go from like 10 to 47, I'll just start here at 5. Okay, and then I'll just go up by like 5s. So let's go 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Okay, so I do a number line that captures all of these data points, right? And so that looks good to go. And then you're going to go and you're going to draw a graph based on these 5 numbers. So here's how this works. You go to a minimum value of 10 and you put a dot. Okay, let's go to quartile 1, 26.5. You're just going to estimate it. It's right around there. Okay, then you're going to go to the median, which is 38, so way up here. Quartile 3 is 42, somewhere right around there, and a max value of 47 would be right around there. Okay, so you have 1, 2, 3, 4, 5 dots. Okay, so the way that you draw this is that you go to quartile 1 and quartile 3. So that's quartile 1. This was the median. This is quartile 3. And you draw actually bars like this at the quartiles, and you make a rectangle. Okay? And then you do, this is the box part, and then for the whisker, you just draw from the middle of the box out to that max value and down to the min value. Okay, this is the median. The median, you would also just draw a line in there. Okay, so I will label this for you. You don't need to label it, but this was our min. This is quartile 1. This is the median. This is quartile 3. And that is the max value. Okay. All right, so you've got your box and whisker plot. This does change if you have outlier values. Okay, so I'm going to just go back real quickly to this last example since we had 2 outliers. Okay, and if I did a box and whisker plot here, we could say, well, our min value was 9 and our max value was 43. Okay, and so I'm going to have to go from 5 up to 45, so I'll do it again. I'll draw a number line, 5, 10, 15, 20, 25, 30, 35, 40, and 45. Okay, and then I will quickly graph my 5 dots. My min value is 9, so I'll put that here. Okay, and then quartile 1 is 22. Quartile 3 is 29. Where's our median? We didn't get the median, huh? Bummer. Sorry, we won't graph the median on this one, but the max here was 43, so I'll come way up here. And I guess the question is, right, we have a problem because this is an outlier. And so is this guy. And if you have outliers, they stay outside of the box and whisker plot, okay? And so this was quartile 1, and this was quartile 3, and so there's our box. So again, this was quartile 1, and this is quartile 3, okay? But then I'm not supposed to connect to an outlier because I want it to show that it's an outlier. And so what do? Well, if that's the min value of 9, you go up to the first number that's not an outlier, 12. Right? And so you would draw your whisker out to 12, and then this guy is a standalone dot because it's an outlier. Same procedure up here. That's an outlier, so I'm not going to connect to it. So I don't want to go up to 43. I only want to go up to 31, which is right there. And so you connect to the next data point that is not an outlier. And you guys can see the whole point of a box and whisker plot is it clearly shows, right? When your box and your whiskers don't touch those values, right? It's not going to say outlier, but you know it is because the whiskers do not touch it. Okay, and you guys will get some examples of that in the homework. And obviously I'll do some stuff in class as well to make sure that we're good to go with the graphing. Okay, all right, you guys, take care.